What is something that, looking at that equation, you can just fill it in for here for right now.
X and the y? I mean the slope, the y and the slope.
The y-intercept and the slope you can see right from that equation, right? This is in slope-intercept form, so you know you can fill in the slope and the y-intercept right away. What is the slope?
-1.
So we're going to write m equals -1/4. That shows up as the m. Y equals mx plus b. Okay. What about that y-intercept?
0,
0, 7. Very good. We have to make sure it's written as a point, so we're going to write 0, 7. We make sure that we don't just write 7 because it's 0, 7. Yes, this number right there is going to show up in our y-intercept, but we have to make sure we write it as a point. It's always 0, y. For the y-intercept, the y has to be a number. Because we don't want to move left or right at all. We just want to go up or down to that y value for our y-intercept. Okay, the x-intercept is the tricky one. Does anyone have any ideas of how we can go about finding the x-intercept here? Or what the x-intercept looks like? What's that? Yep, that's what we're looking for, is where it crosses that x-axis, but how are we going to find it? What do you think? You could make a graph. That'd be one option, but there's a better way, because graphing sometimes takes a lot of time. Plug it in. What do we know this point is going to look like? What does the point look like? We know one of the variables.
7.
No, the 7 was out here on the y-intercept. But remember how in your y-intercept is always 0, y? What does your x-intercept always look like? X, 0. So we don't know what the x value is, but we do know that the y value is 0. So that means that I'm not going to plug in an x, and I'm going to find my x. But since I know the y value, I'll plug it in. 0 equals -1/4 x plus 7. And I know, because I've practiced solving equations, how to solve that equation and get x alone. How am I going to solve that equation? Subtract the 7. 0 minus 7 is -7 equals -1/4 x. Well, let's let that refocus. There it goes. Okay. Now how do I get x alone? Multiply by what? How about +4? If we multiply by 4 on both sides, or -4, that denominator is going to go away. Remember that? So -4 and -4, those are going to go away. We'll have x alone on this side. And you could type that into your calculator if you're not sure. -1/4 times -4, that's just 1x. On this side, what's -4 times -7? Not 42. +28. Right? Which we could have done on your calculator. +28. Okay? So we can kind of picture where these points are located. If I were to do like a sketch of my graph, it would look something like this. 0 at 7. So this would be 0, 7. 28, 0 would be way down here. And I'm going to do that just because I want to make sure that that slope appears to be negative, because I have a -1/4 slope, and I just want to visualize that, make sure it makes sense that I'm headed in the right direction. And it appears that way. I could find the slope between those 2 points and verify that my slope is still accurate, but I don't need to go that far. Does that make sense? We talked a little bit about the x-intercept, but we didn't show the algebraic way in finding it. So I wanted to show that to you. How about finding the slope for these 2 points for numbers 2 and 3? Go ahead right now. I'm going to give you a minute to go through and try to find that slope. So many of you guys got to this point where a number 2, you had like negative 17 on top and 0 on the bottom. Or maybe you had 17 on top and 0 on the bottom. And either are going to get you the same answer. What is your answer? Type it in your calculator. Everyone take out your calculator right now. And type in negative 17 divided by 0. What is negative 17 divided by 0? What's it say on your calculator? It says error. What is that slope if I divide by 0? No. Your calculator told you error. It's undefined. Okay? And if you need to, sketch your graph here. Here are your axes. 1, 7 is here. 1, negative 10 is here. What happened on your ski trip when you had a vertical slope? We don't know. It's undefined. So your M, your slope, is undefined. You have to write undefined on that. No other option is acceptable. Okay? What happens when we take 0? Most of you guys got to this point too, where you had 0 on the top, and whether it was negative 10 or possibly 10 on the bottom. What was your slope if you do 0 divided by negative 10? Type it in your calculator. This one's a little easier in your calculator because your calculator tells you the answer that you need to see.
0.
It's 0. So this slope is 0. Again, we can sketch this. And 3 is at negative 4. And negative 7 is at negative 4. So you have this horizontal line. How fun's your ski trip with a horizontal slope? 0 fun. M is 0. So visualize those points, plot those points, because if you get something funky in your fraction of your slope and you're not sure how to simplify or reduce that fraction, sketch what the slope's going to look like. And maybe that, the vertical line, you'll remember, is undefined, and that your ski trip is 0 fun when your slope was horizontal. So if you can visualize it, you can sketch it, that might help you remember those slopes. Okay. All right, so that might become very useful for your quiz for this weekend. All right, so next we are going to do our notes for today. And then after notes, we'll take a break. So open up to your lesson 2, day 2 notes, which look like this. Okay, so our goal today is to graph and write linear equations using all 3 forms. All right, so we have 3 different forms of linear equations. They are the slope-intercept form. That's the one that we already know. What does the equation look like for slope-intercept form? What's that one look like? Y equals mx plus b. Thank you. Okay, we have some information about it. M represents something. What's M represent? The slope. And what's the other key information that it gives us there? The y-intercept. The y-intercept here is 0, comma, that b value. Okay. This is really good for graphing. It's usually pretty easy to graph if it's already in slope-intercept form. It's very good for finding the slope because you can see the slope from it. Or finding the y-intercept because you can also see your y-intercept by just looking at the equation. Point slope form and standard form are the other two forms. Now these are not used as often as slope-intercept form, but it's still important that we know them, we recognize them, and we know what they're good for. So point slope form is y minus y1. Now when you write y1, I'm going to zoom in. y1, it's a small letter down below the y. Okay, it's not up at the top. Because if I wrote it up here, that's an exponent. And we're not writing exponents. So I'm going to make sure I put it down here, y1. Just like we did when we wrote the slope formula. So y minus y1 is equal to m, there's that m again, times x minus x1. That x1 is written the same way that other one was. Okay. The information here is that m is still going to be your slope. The x1, y1 is a point on the line. Okay, this is really useful. You can graph from this. It's good for graphing. But it's also good if you're given a point and slope. If you're given a point and a slope, you can very easily write your equation in point-slope form. And then from there, if it says your answer is supposed to be in a different form, then you can work at changing, moving things around, manipulating the equation to make it look like whatever you need it to look like. Now, standard form. Standard form is a capital A, lowercase x, plus capital B, lowercase y, equals a capital C. Okay, the A, B, and C are all capitalized. The x and y are lowercase like they always are when we write them. Now, when you're writing an equation, you need three things in order for it to be an equation. You have to have an x, you have to have a y, and you have to have an equal sign. Okay? So when you're writing an equation, there's your checklist. Do I have an x? Do I have a y? Do I have an equal sign? And if you have those three things, you're at least on the right track. Okay? Everything else has to be numbers. You have no other variables in there. An x, a y, an equal sign, everything else is numbers. The information here is that A, B, and C, those three capital letters, must be integers. There's that word from 1.1. Now this makes sense why Mrs. Fox put it on every single quiz to put your numbers in the right sets, because you have to know what are integers. Okay? Does anyone remember what integers are? They can be negative. What else? They can be negatives. They can be positives, but they're counting numbers. So this word integers, if you need to write it down, this is something that you guys have been asked multiple times. These are numbers like -3, -2, -1, 0, 1, 2, 3, so on and so forth in both directions. Okay? They're the positive and negative counting numbers along with the 0. Okay. Standard form is really good for finding intercepts. So finding x and y intercepts. And I'll show you how to do that in a little bit. But that's kind of the key thing that it's good for. All right, so the very first thing we're going to do is we're going to write an equation for the line that's described, and we're going to write it in point-slope form. So we're going to write it in this form right here. So again, I know I have to have the y, I'm going to have the equal sign, I'm going to have the x. Everything else is going to be filled in. Here's the point. That point is x1, y1. They gave me m is -5, so I'm just filling in all the parts to this equation. Y minus y1. Well, y1 is 9, so minus 9. The m value, which comes next, that's in front of the parentheses, is -5, so I'm going to fill that part in. Then I have x minus x1, so minus x1 was 2, and close that parenthesis. And I just wrote the equation for the line that's going through this point and has a slope of -5. Let's try the next one. B.
Yes.
Okay, go for it.
So x1 is -1.
Uh-huh.
Then y1 is 7.
This is y1, yep.
And then it'll be y minus 7
Yep.
equals -4 over 3
Very good.
parentheses x x minus -1.
Yeah, but what happens when you minus a negative?
X plus 1.
X plus 1. Excellent job. Yes, when you subtract a negative, you're actually adding. I want everyone to try C on their own. So you should have y plus 5. Some of you wrote y minus -5, which is okay, but then you're just going to want to do one more step and simplify the y minus -5 and make it y plus 5, because that's simplifying. We don't like two negatives next to each other. You subtract a negative, it turns into plus. Adding. Okay. All right, the next type of problem that we're going to do is we're going to learn how to convert a linear equation to standard form. So to do this, the first thing you want to do is you want to move your x and y terms to the left side. So it depends on what you're given, but we're trying to make it look like this. Your x and y terms have to be on the left, and just all the numbers are on the right. Okay, so the number is on the right. So you move your x and y terms to the left side. The next thing that you're going to do is you have to get rid of any fractions by multiplying by the denominator. Because our rule says that those numbers, A, B, and C, are not allowed to be fractions. They have to be integers, like these counting numbers. So you have to get rid of any fractions by multiplying by a denominator. And it really doesn't matter the order that you do these two things in. Some people prefer to get rid of the fractions first so they don't even have to work with them. Other people like to move their terms all in the right spot and then work at getting rid of those fractions. All right, so let's check out A. We're going to write this in standard form. So we need the x and the y on the left side of the equal sign. The y is already on the left side of the equal sign, but the x term is not. So what we can do first is we can subtract 2/3 x on both sides. That term goes away on the right, and on the left you have -2/3 x plus y equals -7. Yes.
When you, since it's like a type of form of division for the two zeros, when you multiply?
We're not multiplying or anything. You just subtracted the term.
Oh.
You're subtracting the term. You're not doing anything with division. So you're just subtracting the term on both sides to move it to the other side. Okay? So that's why it was a positive, now it's a negative because it's on the other side. Okay? Now, I do have a fraction there that I need to get rid of. So what do I need to do? I need to multiply by a denominator. So what's the denominator right now? 3. So I have to multiply all the terms by 3. So I'm going to multiply this first term by 3, this term by 3, this term by 3. And now, negative 2 times 3 and divided by 3, those go away, and I'm left with negative 2x. Because if I multiply by 3 and divide by 3, which is exactly what's happening in the negative 2 there, the 3's go away. Plus, 3 times y is just 3y, is equal to 3 times negative 7 is negative 21. Now this is in standard form. It's in the form of ax plus by equals c. Your a is negative 2, your b is 3, and your c is negative 21. Negative 2, 3, and negative 21 are all integers, so that works. My x and y are both to the left of my equal sign, and the numbers on the right. So that's in standard form. Now, I told you that if you don't want to deal with the fractions, you can get rid of those first. So let's try it that way on this one. What am I going to multiply by in order to get rid of fractions? The what? A denominator. So which denominator do you want to multiply by? 2 or 4? 2? Okay, so we're going to multiply this term by 2, multiply this term by 2, and multiply that term by 2. This term is being multiplied by 2 and divided by 2, so now I just have one y. Or I can just write y. This term is going to be negative 6 over 4, because 3 times 2 is 6, so I have 6 over 4, x, plus 8 times 2 is 16. Now what should I do? I'm going to have to multiply by the other denominator. Now, wait a minute though. See that fraction right there? It can reduce. That's the same thing as negative 3 halves. So am I going to multiply by 4? I don't have to. I only have to multiply by 2. So I'm going to multiply everything by 2 again. So 2 times y is 2y. When I multiply by 2 and divide by 2, that's just going to be negative 3x. Plus 16 times 2 is 32. Am I good? Is that in standard form? Why not? The x is on the wrong side. Okay, so I have to move the x over to the other side. So I'm going to add 3x on both sides. My 3x is no longer on the right side. How do I write the left side? Yes, 3x plus 2y equals 32. That is in standard form. Now, if you would have forgot to reduce that fraction, you would have just had 6x plus 4y equals 64. All of those numbers would have been doubled, which technically is the exact same function. It's the exact same equation. It's just another version of the standard form for it. Yes?
Would you also accept that other version as well?
Yeah. Yeah. But one thing is that you guys will want to be aware of that, because when we're checking your homework, I'm not going to have every single form on there for standard form. I'm going to have probably the most reduced answer on there, as if I would have reduced. So you guys would have to be able to recognize if it's right or wrong. And you can always ask, but I just wanted to let you guys know that that's what can happen. Also, you could have done this one in less steps. If we multiplied by 2 and multiplied by 2 again, what number did we actually multiply by? What number did we multiply by if we multiplied by 2 and multiplied by 2? 4. I see some of you guys showing me. 4. You multiplied by 4. If you would have picked this denominator first, the larger one, and multiplied by 4, that fraction would have gone away anyways. Because when you take 4 and multiply by 1/2, you'd end up with 2. So it's okay if you choose the smaller denominator, but sometimes if you choose the larger denominator, like 4, then you can do it in less steps. And we would have only had to multiply by one denominator and we would have been done. So I just wanted to show you a couple of those things. This one's a little bit different. This one has parentheses in it. This one was given to us in point slope form. So we're still going to have to move the x term and the y term to the left side and the numbers to the right. But the problem here is that I don't even see the x term because it's inside parentheses. So you're going to have to start by distributing that in order to get rid of those parentheses. So y minus 2 equals 6 over 7x plus, 6 over 7 times 2. 6 times 2 is 12. You have to think about that as over 1. So that becomes 12 over 7. Ooh, well that looks ugly, doesn't it? Divide by 2. What can we do to get rid of those fractions because they look so ugly? Multiply everything by 7. So we're going to multiply this by 7, multiply that by 7, multiply this by 7, multiply that by 7. 7 times y is 7y, minus 7 times 2 is 14. 6 times 7 divided by 7, my 7s are going to go away and I'm going to be left with 6x, plus 12 times 7 divided by 7, the 7s are going to go away and I'm going to be left with 12. Well, that looks quite a bit more friendly, but I still have some moving around. What do I need to move? The what? Yeah, the 6x has to be moved to the left side. So if I need to get rid of it on the right side, I'm going to subtract it. What else is going to have to move? The 14. So I'm going to have to move it from the left side, so I'm going to add 14 to both sides. That goes away there. That goes away there. On the left side, I have two terms, negative 6x plus 7y. I'm going to always make sure I write my x term first, too. You always write the x term and then the y term. So negative 6x plus 7y equals 12 and 14 added together. It's 26. Okay. Once you have that copied down, go ahead and flip your page. So we actually just did a problem that was written in point slope form, and we converted to standard form. And this next set of directions says, write an equation in standard form, which is what we just did, given the slope and a point. And if you're given the slope and a point, the first thing that you're going to want to do is write it in point slope form. Point and a slope, write it in point slope form. Okay. Sorry. That's not where I'm writing. I'm writing up here. Okay. Once you have it in point slope form, then you're going to, just like what we did in that very last example, the first thing we did, I'll try to refer back to it, we distributed the slope to get rid of the parentheses. So that's what the next thing is going to be. Distribute. That gets rid of parentheses. So you're going to distribute. And then after that, you multiplied by denominators to get rid of fractions. But then we're not done. We have to add a fourth step here. Your step 4 is to move the terms, move the x and y terms to the left and the number on the right. And 3 and 4 can be changed. It doesn't matter which one you do first. As long as you do get rid of the fractions, and as long as the terms are in the correct locations, you are golden. So, we already practiced writing these 3 things in point-slope form. You're given a slope, you're given a point. So you're going to write it in the y minus -3 turns into +3 equals your slope, the m, times x minus x1 is 10. Okay, go ahead and write v and c in point slope form also. You guys have done that part, so you go ahead and do that part. All right, so we should have been able to come up with the point slope form. Give me a 1 through 5. I did an excellent job writing my point slope forms. Down to a 1. What'd I do? Good. So we're doing okay doing that part, right? Okay, good. Now, the first thing we're going to do is we write it in point slope form. Cool, I did that. The next thing we have to do is distribute to get rid of the parentheses. Okay, so we're going to distribute this 1/2. We're going to get y plus 3 equals 1/2 x minus 1 times 10 is 10 halves. Can 10 halves be reduced? What's 10 halves? Yeah, -5. So I'm just going to erase this, and I'm going to write 5, because I know that that's 5. Is that okay? Are you guys with me? All right, then the next says to multiply by the denominator to get rid of fractions. So what am I going to multiply by? By 2. So times this by 2, times that by 2, times this by 2, times this by 2. All right, 2 times y is 2y. 2 times 3 is 6. 2 times 1 divided by 2 is going to be 1. So just x, I don't have to write 1x. I can if I want, but 1x. Minus 2 times 5 is 10. All right, I'm almost there. Next, I have to move the x and y terms to the left and the numbers to the right. So, I have to move my x term to the left. That'll get rid of that there. The 6 is going to have to move, so I'm going to have to subtract 6 on both sides. That's going to go away there. On the left, I'm going to have negative x plus 2y equals negative 16. This next one's even easier. What do I do first on this next one? Distribute that -2. Why is this one easier? Why do I know that by looking at it? There's no fractions. So y minus 11 equals negative 2x. Negative 2 times 7 is minus 14. What has to move here? That negative 2x, so I'm going to have to add 2x on both sides. What else has to move? That negative 11, so I'm going to have to add 11 to both sides. Notice when I'm writing it, I'm lining up with the like terms. That's why the 2x doesn't line up with anything, because there's not a like term for it. 2x plus y equals Negative 14 and 11 is going to be a negative number. And negative 3, yep. And that one's already done. I didn't even have to multiply by the denominator to get rid of a fraction. Try the next one on your own. Try this next one on your own. So that looked pretty good coming around. Excuse me. Negative 8x plus y equals, some people got mixed up with positive 4 versus negative 4, but overall, most of you guys were able to come up with this, so very nice job. Always use your calculator if you're not sure. 8 and negative 12 is negative 4. Your calculator will tell you that, okay? How to write an equation in slope-intercept form given the slope and a point. Okay, so if you're given slope and a point, what form should you write it in? If you're given slope and a point, what form should you write it in? Point slope form, because those are the two things that you're given. So you're going to start by writing it in point slope form. So even though point slope form isn't all that useful when it's given to us, it is because there's so many times that it's easiest to write it in that form, and then we'll switch it to the form we need it to be in. Okay? So we're going to start by writing it in point slope form. Then we'll convert it to slope intercept form. All right, so it says write an equation for the line described in slope-intercept form. So we have to write it in slope-intercept form. And notice we're given the slope and a point. And then it says we have to graph it. So looking at this, if we're given a point and a slope, we should write it in point-slope form. So that's here's x1, this is y1. Y minus y1 would be y minus negative 3. Which turns into y plus 3, equals our slope, which is negative 1/2, x minus x1, which is minus 6. So there's my first step. Now slope-intercept form. What does slope-intercept form look like? Yes, that's the y equals mx plus b form. So sometimes it's easy if you write that down. When you're reading the directions, write an equation for the line described in slope-intercept form. Write what it's supposed to look like right above it, so that when you write your answer, you can make sure it looks right, like what it's supposed to look like, because it's going to tell you what form it wants your answer in. Okay? And once we have it in that form, we're good. We're golden. We know how to graph it from there. Yes.
Do you want us to memorize that form too? Formula as well?
Well, you should have them memorized. It'll make it easier. But if you can't remember it, all your quizzes are open note, right? So you can always resort back to your notes. But yes, it's much easier if you write this down every time, so you always have it to look back at. Okay? And the more you write it, the easier it is for you to remember it. All right, so here on this one, we need it to look like y equals mx plus b. So this one has parentheses. Our y equals mx plus b does not. So the first thing I want to do is I want to distribute that number right there. And when I do that, I didn't change anything on the left side. Negative 1/2 x. A negative times a negative is going to be adding. It's going to be plus 3. 1 times 6 is 6. Divided by 2 is 3. Yes, a half of 6 is 3. Okay. Well, I still have to get y alone because this one looks like y equals. See how y is alone? So what do I do over here? I don't have to get rid of fractions this time. That's not one of my rules. I'm going to have to subtract 3 because I don't want anything else with y on that side. This rule doesn't say anything about fractions, so I don't have to do anything. Yeah, m can be a fraction, and b could be a fraction if it really wanted to be. That'd be a pain to graph, but it could be. Okay, so our equation here, let me try to rewrite this, make it a little bit easier to see, is y equals negative 1/2 x. Your 3's actually went away on both sides because when you subtracted 3 minus 3 is 0. How do I graph the equation y equals negative 1/2 x? I need to make sure I know my slope, and I need to know my y-intercept. So what's the slope of that graph? Y equals negative 1/2 x. What's the slope? Negative 1/2. What's the y-intercept? 0. So if you need to write in plus 0 here, you can to remember that that y-intercept is at 0, 0. So we'll just use scales of 1 here. 0, 0 is our y-intercept. And that slope, how do I move if the slope is negative 1/2? How does that move? Down 1, right 2. Or you can go up 1, left 2. And you're going to have to go both ways because we've got to fill in our whole graph. We're going to plot every point that will fit on our graph. Then we'll use a straight edge. And connect those points. Now I should probably check that there's a specific point on my graph. What point should my graph be going through? It should go through 0, 0 because that's what my y-intercept is. But look, it said it has to go through 6, negative 3. Did this graph go through 6, negative 3? Let's check. Right 6, down 3. Did it go through it? Yeah. So always double check that the point it's supposed to be going through, make sure it went through that point. All right, let's try the next one. Start by writing it in point slope form. So we're going to have y minus 1 equals the slope is 2 times x minus negative 2 turns into x plus 2. Distribute that slope so you can get rid of those parentheses. So y minus 1 equals 2x plus 4. What's the last step I have to do? How about add 1? Yes, add 1. So you have to undo it. So you have to undo it, you got to do the opposite. So y equals 2x plus 5. All right, I still have to graph that. What's my slope there? 2 over 1 or 2. What's the y-intercept?
5.
Oh, don't do that. 0, 5. Okay, so 0, 5. So I'm going to plot the point 0, 5. Right there. How does the slope tell me to move? Up to right 1. I ran out of space, so I'm going to have to go the opposite direction, down 2, left 1, until I run out of my graph. I'm going to connect these with my straight edge. You use the edge of your binder, folder. Okay. What point should I double check and make sure this is that is on my graph? Negative 2, 1. So go to the left 2, up 1, Negative 2, 1 is right here. It is on my line. That line I can see has a slope of 2, so it's looking pretty good. Let's try the next one. I'm going to show you a different way you could do this one. If you are required to graph this, graph the point 5, 7 first. How do I get there? How do I get to the point 5, 7? Go where?
5 over 7.
Yep. Right 5. Up 7. Which is this point right here. If you know that that's your first point, you can plot it. And then, what's your slope from there? 2 over 1. So how do I use my slope? What's my directions here? Down 2 over which way? Down to left 1. Because I can't go up to right 1, so I have to keep going down to left 1. Cool, I have my graph done. That was simple. But what was I supposed to do? Slope-intercept form. So now that you have your graph, could you write this as y equals something x plus something? Could you fill that in? What's your m? 2. Y equals 2x. What's your y-intercept?
7.
Your y-intercept is 0, comma, negative 3, which you can see from your graph. So your equation is y equals 2x what? Minus 3. Because you have to find that y-intercept from looking at your graph. So you could work backwards. You could graph it first and then go and write your equation. Some people like to write their equation in point slope and then convert it. But if you have to graph it anyways, that would also work. Just do your graph first. Okay. All right, so calculate your x and y intercepts. Plug in the variable that you know as 0. Okay? An x-intercept is always x comma 0. Your y-intercept is always 0 comma y, meaning you always know one of your variables as 0. So step 1 is to plug in the variable that you know. Okay? If you're looking for the x-intercept, you know y is 0. If you're looking for your y-intercept, you know that your x is 0. Okay? And then you solve for the unknown variable. So here's an example. Y equals 7x plus 4. If I want to find my x-intercept, I know that that point looks like what? Something 0, right? So what I'm going to do is I'm going to take my equation, I'm going to plug in 0 for y. 0 equals 7x plus 4. How do you get x alone? Subtract 4 on both sides. Then what? Divide by 7 on both sides. X is negative 4 over 7. Don't go to your calculator. We don't care what your calculator says. We know that that's the fraction. We don't put it as a decimal because that would mean we'd have to round. So would it be exact? Okay, we're still working on the exact same equation. And we want to do it with our y-intercept. So what's the y-intercept look like? 0, comma, whatever that y is, right? So we can do that the exact same way. We take our equation here. We don't know y. However, we know that x is 0. Oh, look, y is already alone. Y is going to be 0 plus 4 is 4. Which in that case, you could have found your y-intercept because it's already in slope-intercept form, right? But it still works if we plug in that 0. Okay. So that's all I have to show for you. We will take a quick break.